Hi, I'm Greg Cheney. I'm from Juneau, Alaska, and I'm just pointing out a Yokalop event, or a glacial outburst flood, as it's more commonly known. This is my property, and as you can see, I can't even get to the edge of the river because it's flooded in the forest here. And glacial outburst floods are caused by ice damming a glacial lake, and then at some point it'll break. Glacial outburst floods often happen without any warning, especially if the area where the lake that is being dammed is not being monitored. The lake will fill up, break through the ice dam, and descend on the valley below, even in sunny, dry weather when you wouldn't be expecting any flooding at all. For this reason, I was very excited when Dr. Higman invited me to come along on a research project to help video several researchers who are taking a multidisciplinary approach to Yokalops in the Lituya Bay area.
The purpose of this expedition is the first part of a PhD project that I lead, and Natalie is the PhD candidate in that project.
My name is Natalie Litzo, and I'm a PhD student at the University of Potsdam, and I'm doing my PhD on glacier-related hazards in Canada and Alaska, in the glaciated mountain regions here. Yeah, we are here in Lituya Bay because we found a huge lake behind Lituya Glacier, which is called Desolation Lake, and I was particularly interested in this lake because we saw that there are very frequent outburst floods. Yeah, there are a lot of things going on here, and we saw that there's a huge delta that accumulated, so we're here to get some field evidence and get some insights into the sedimentary record, which might be very useful for other locations to get a better understanding what's going on with these outbursts.
My name is Brentwood Higman. I have a PhD in geology. I studied tsunamis for a long time, and I've recently been studying landslides, and I run a small nonprofit and work with a lot of different scientists. I kind of end up filling an informal guide kind of role. I see my job in that case to be sort of like a guide, but that the priority is always on the science. Like, I want to make sure that, top priority is safety, and that really is my top priority. I try to make sure people are safe, but when it's a question of, like, what do people want to do, it's always a question of, okay, how do we get the best science done while we're here?
You can get to Lituya Bay by boat, but we didn't have that option. It's an open ocean journey with a very narrow and tricky entrance. Many people have died getting to Lituya Bay, so we opted to fly. We chartered a float plane, and the thing about an airplane is it has very strict weight limitations. We were paying attention to this, and the day before we spent hours weighing everything and trying to calculate our weight as close as we could. But when we got to the airplane hangar, it turned out that we were 260 pounds overweight. There was no negotiating with the pilot. We had to get rid of 260 pounds, and we didn't have very long to do it.
I could probably take everything out of the case. That was like probably a few pounds.
We're trying to reduce the weight for the airplane here.
Ended up leaving a lot of our food behind because we didn't want to lose the scientific potential of the trip.
Woo! Can you? Keep the shovel.
Everybody wave!
Woo!
The important piece, right?
That's it up there.
Have all your
Oh, batteries. Sure. We established 2 camps. One lower camp, which was mostly where our food was going to be, along with some other gear. And we put that inside electric fence to keep it safe from bears.
One of our concerns here is potential for bears to get into our gear or into our camp. And so this bear fence, an electric fence, is to keep bears out. I think they're a really good way to go because the bear comes up and takes a look and sniffs this line, it gets a zap in the nose, and they tend to really remember that.
And then we established an upper camp that was intended for sleeping primarily. That's where our tent for sleepings were.
These ones are. I don't know if it goes outside or inside. We do have a ground.
You can, so the way this one's set up, I mean, it's not that bad because it's down on the ground. Oh no. Put more rocks is not a bad idea.
We're just tying all these ends off. Just put this down here.
That turned out to be a pretty good system, although it did take a long time to walk from the lower camp to the upper camp. So if you got down to your lower camp and you forgot something, you had to walk all the way back to the upper camp and back down. It was actually quite a long distance, but it worked out well, and we didn't have any bear problems.
That was great. I'm Georg B. and I'm a postdoc at Potsdam University. And this bay is special because we have here a bunch of different hazards. We have tsunamis, we have glaciers that are retreating, which are forming huge lakes, glacier-dammed lakes, and these lakes can drain very rapidly in glacial lake outburst floods and form then again huge deltas. So this is a hazard cascade that we are observing here, and this is why we came here.
At the head of Lituya Bay are the Lituya and Krillian glaciers. These glaciers are mirror images of each other. Both glaciers form ice dams and are holding back large lakes. When these lakes rise to critical levels, the ice dams break, releasing massive outburst floods. Over time, these floods have built significant deltas. Using satellite images, it is possible to trace the rapid expansion of these deltas since the 1980s. One dramatic feature of delta formation on the Lituya glacier side has been the shift of the outflow from one side of the delta to another. This reflects how water flowing under or through the glacier ice has dynamically evolved over a short period of time.
These are our pressure gauges, so they'll measure air pressure or water pressure, and so water pressure you can convert into water depth, and so that's really what we're most interested in here. And so I'm just putting the wire around it to provide a little extra protection. It's kind of like a little scuff barrier. I'm also just trying to learn these instruments a little better because I haven't used them a whole lot, and we're going to deploy some that'll be left for a long time in the lakes. And so, for example, the most important one will be, if possible, one that'll be in Desolation Lake, which occasionally drains catastrophically. So it will be a way of recording the filling and draining of the lake.
Yeah, we are studying Desolation Lake, the lake behind Lituya Glacier, because it's producing a lot of outburst floods, and it's a unique site for us because we see that the lake is growing and producing these outburst floods, which is different from what we see for most of the lakes over the world. Usually we see that they are growing and then they start to outburst, especially the ones that are ice dammed, and then they decline in size, and we expect also a smaller outburst, but outburst floods. But yeah, that's not really what we see here. So it was a great intention for us to, like a reason for us to get here to see what's different here than in any other locations we seen or visited before.
See you guys soon.
Yeah.
Bye-bye. Bye-bye. We're turning around now.
Discretion is the better part of valor.
And then we had to change plans pretty quickly. And it was like,
So we're kind of on Lituya Glacier right at this divide where it flows both directions and it forms a dam in this valley, and so the valley is filling up with water as this big lake called Desolation Lake.
Hey.
And every once in a while it drains out really rapidly.
I'm in the lake. I'm standing in the lake. Amazing. I never thought it would happen. Now I've got to survive getting back. So what do you think, Hig? Is there any point in putting a pressure gauge here, or are you going to go somewhere else?
Well, in some ways, well, there are a number of problems. There are a number of problems with this site. One of them being that, I mean, this boulder sticking out of the water,
Yeah.
it might be enough to protect something if I tied it on this side.
Yeah.
It might be protected from drifting icebergs, but imagine if the water is 30 feet higher here and there's an iceberg that just at the bottom comes
sure.
dragging along, the amount of force
Yeah.
involved.
No. Okay.
It's a little tempting. You see this nose over here,
Yeah.
and you can see the shorelines on it.
Right.
So that shows it's not getting altered by other processes much. It's not very far.
Yeah.
I'll probably paddle there and back,
Okay.
but there are a bunch of challenges definitely still.
So here we are at Desolation Lake.
Where did you first see it?
I think it was Martin Gertzema who told me, I think 3 years ago, that there are massive outburst floods and the Lituya Bay is full of glacial flour, and there must have been a huge flood. And then we looked at the satellite images and realized, oh wow, this lake drains every year, and these floods are just huge, one of the largest ever reported. So this is why we came this year here and to study it a bit more.
Oh, there he is. He didn't. It made walking up there look pretty easy.
say what?
How far above the water level do you think that is?
The pressure gauge is now installed 11.9 meters above the lake level, and we hope that the lake level will rise until that point and that we can measure the drawdown during the flood.
Some efficient cheese.
This is quite good without sausage or cheese. I'm Martin Gertzema. I am a hazards geomorphologist from British Columbia. I'm on the committee actually of Natalie, who's a PhD student studying glacial outburst floods of Lituya Glacier and Desolation Lake. And my role here is to help support that and to be part of the team studying this event. This is a very dynamic glacial landscape. We've got two large glacial lakes along the Fairweather Fault on Crillon Lake and Desolation Lake, both dammed by glaciers. Both of these sites are producing very large deltas in the last decades that empty into Lituya Bay. They're at the head of Lituya Bay. And there are a whole suite of hazards, potential hazards, associated with these things. As these deltas build, partially from floods and partially just from meltwater under the glaciers. They can experience loading from the accumulation of sediment on the glaciers, but also potentially from landslides. There are a tremendous amount of landslides in this area.
Yeah, what I'm doing here is basically focusing on the delta area. So I'm doing a lot of photogrammetry surveys of the boulders we find there to get a bit of insights on their shape and distribution across the delta. So we have these surveys to have, in the end, 3D models of these things. And yeah, so that's what I spend the most time here on. But I also like to get more insights into that, what other people do in the group, because of course it's also a great learning experience for me to be in the field with other researchers.
So that upper vegetation line marks the height of the slope.
I think that's the high water mark.
The high water mark.
All right.
And
That's it.
I'll add that I was walking by blindly and that Ole noticed it first, but I'm telling his story.
The trim line on the other side, you know,
Yeah.
but that's all bedrock and we didn't find anything.
Yeah,
There's
yeah.
a little, you know, a few nooks and crannies.
I think this is talus.
This goes to,
Well, Ole pointed out that ice terrace there, so there's glacier ice. And then we were thinking about all these depressions that look like kettles and these longitudinal cracks and transverse features.
Yeah.
So we think that all this flood debris is sitting on glacier ice.
Right.
And Ole also mentioned that the artesian pressure that we saw in that one place is consistent with that.
So that would be the ice melting and upwelling?
the groundwater being forced over the ice.
Oh, okay.
Just trying to...
Yeah.
So what I believe, what I see here, is that this was once the source of the floods, which is now sealed again with ice. But the floods then took that route and then went down along the terminus of that glacier. But what we believe is here, if you see that here, that there was the erosion of that bedrock canyon, which seems to be pretty impressive actually. So what we see here is a striking contrast between the two lithologies, right? What is lying on top of the glacier, this debris, is a completely different material than compared to what we see in front of the glacier. And this is just all the stuff that is lying around here is what the floods have transported. And this is just what the glaciers have transported. So it somehow supports the theory that the floods bring other material than the glacier, at least the glacier on top, transports.
What is everyone thinking about? I wonder if we're going to be able to...
It's hard packing up tents in the rain because then they get so wet on the inside, you know?
Yeah.
Tonight is supposed to be more rainy.
Yeah.
And I mean, I don't think we can predict the difference between slightly more than this and, like, you know, a really intense deluge.
It's pretty cozy in here.
Pretty cozy in here.
That's absolutely true.
Yeah, it's not just this diverting this way. It's the whole thing has come up, and yeah, it's very convenient if all of your gear is just floating with you down to you.
I don't...
The box that I wonder. blocking the trail over the mountain. The super remote place.
Huh. Confidence.
Let's see what we have here.
Harps.
So you might be thinking this is rain in the background, but it's applause. Come through here. Up.
Well, it's shaped. It's got an oval shape.
I'll put this wood here.
All about clever cheats. So yeah, I've set up a couple of pressure gauges here. That pressure then I can equate to a rough water level. And so this will, for instance, measure the tides here, which is a little bit interesting. Like it's we're not in a place where there's a lot of tide measurements, so kind of curious to see that. However, it will also measure, it's measuring every 10 seconds, so it will measure weird waves and stuff that happen within the bay. It'd mostly be things like seiches, so harmonic waves, and conceivably tsunamis. Seiches could be excited by various different things. So yeah, and the data on these is actually recorded on the unit, so we have to retrieve it and also reset the unit to record more. We're going to deploy another pressure gauge. We've put a few of these out. Leave this one for a year to 2 years. And I want to try to use this metal to hold it all together. I want to make sure nothing can chew through it. This notch in it. This rock here is to anchor it down so it doesn't get swept around by currents and little waves and stuff. I need to remember when I come back bring wire clippers, because some of these things will be kind of difficult to get apart. Yep, I'm gonna go deploy this now. So I want to lower it down. Ideally, I'm gonna get to below the lowest tides, and I'm not gonna drop it partway through the process. This is one challenge of using this thin cable, is can't really hold on to it very well. What I'm actually more interested in is these outburst floods, and
So how is this going to tell you about that?
they will probably raise the bay level. Expect to be as much as a couple meters.
Okay.
Maybe, you know, in the extreme.
Along with the pressure gauges, Higg installed 3 time-lapse cameras that were aimed at areas of interest on the outwash plain, where the hope was that these sequential images would show sediment transportation and deposition and flooding at different points in time. This was a great opportunity to collect images which could document how the landscape was changing over time. So how many limbs do you need to clear to get a good setup?
I want to get some above to prevent snow and shadow. I don't want shadow on the solar panel, and I don't want branches to hang down and obscure it with the snow. And then I also want some below, because it's somewhat wide angle camera, and so it needs to see around things. So yeah, we just installed a camera up here, which is looking out over this this delta. And lately the big outburst floods coming from the glacier have been coming from right there. So this will be looking straight on as they come out. We'll hopefully get a really good record of those events.
I'm in Lituya Bay to do a bathymetric survey using a multi-beam sonar. to look at the lake morphology and look at how the volume of sediment in the lake has changed since the last time it has been mapped. For my PhD and prior to that I studied landslide generated tsunami, mostly in lake settings, and for that work I used a similar setup but on a bigger boat.
I've actually never been involved in a bathymetric survey, so using this instrument to look at the bottom of the ocean has been really a learning experience for me. But one of the challenges we had is that we didn't have any vessel at all to mount this very fancy instrument on that takes this picture of the bottom of the ocean. And so we discussed this, like, is it possible to somehow do this off of pack rafts? And after a number of discussions, we came up with this idea of this catamaran with 2 big pack rafts held together by 2x4s, and that's partly because you can get a 2x4 pretty darn easily. So we just picked up some before we got on the float plane. And it has a few other bits and pieces, used a little trolling motor. We ended up using these deep cycle marine batteries in order to run the boat.
Snugging that down, huh?
Yeah, we don't want this to come free.
The benefit of having a multi-beam on a pack raft catamaran is that you can access places like Lituya Bay that are very remote.
You should go look for sunken treasure.
It's interesting what people use this equipment for, like, yeah, heaps of like shipwreck applications.
But yeah, 2 weeks ago we were like, I don't know, maybe this won't work at all. We have no idea. So it's been actually really excellent progress.
I guess one of the unique challenges about a new-ish setup in a remote field setting is our having to fix things on the fly. Yeah, like the trolling motor breaking on our first day.
Melted the insulation at the very least. We don't know if it also did something horrible to the control system.
I think all you need is to separate the wires and insulate the shorted part, and you'll be back in business. That's my expert opinion.
I like it. I'm hoping you're right.
Yeah, based on the fact I've never worked on a trolling motor.
Well, that makes 2 of us. We have gotten some of these zip ties in there in a way that we think is separating the wires. I think we should try turning it on.
All right.
Turning.
No visible smoke though?
No smoke.
No
I don't
smoke.
see.
I reckon we ought to seal it.
All right.
So what's the next step, Doctor?
Glue.
Don't freaking happy.
So tell me about the tide.
Well, I think we did set up here yesterday, but now the tide has gone out, so we have to carry all of our heavy stuff from our bear fence over there to low tide.
Which point?
All the way over there.
Like the purpose of the multi-beam survey here at Lituya Bay is, I think, twofold. The first is to look at the subaqueous morphology of the deltas and of this section of the bay. So looking at the bed forms and delta channels and all of these little fine scale features that you might see on a topographic map that we rarely get to see of the underwater environment. So multi-beam bathymetry is usually done on a big research vessel, so they can't get into like the shallowest parts of the lake like the deltas we have here, and are very expensive to charter and, you know, require lots of a big scientific team to run these research cruises. So multi-beam data is therefore quite rare to get. It's such an interesting setup. It's definitely more unique than most of my multi-beam settings. A little bit colder and wetter, but I think we've done a pretty good job at making this technology that isn't usually accessible for projects of this size.
Oh, nice. All right, this is the map we have so far. This is the data we're collecting. Looks like the bottom of the lake. There's some sediment waves coming off the delta. The shine on this is not good. This is where we can look at the bottom morphology. This is my hunk of cords. Greg and Skipper Martin.
It's funny with the system as complex as the multi-beam, there's so many little bits to get the data that we need that it's like, if one thing breaks, it doesn't work. So yeah, lots of points of failure, but we've managed to overcome any sort of technical challenges we've had thus far, which is pretty cool. We ran the generator from the pack raft
with the laptop plugged in. It really shows the importance of showing up to these landscapes at different times. Like we have here, this little snapshot of what the environment is looking like now is definitely not going to be the same in 20 years. So there's a record of change already going on with depth soundings from the first people who were here doing soundings, and then more recently from the park. And so this is adding to that bigger body of work, looking at how the depth of the lake and the volume of sediment that is coming into the lake has changed over the years.
Yeah, you can look at
the channel.
In theory, if I had it all nailed, we could
Can you see? You can see here, there's like the big channels that are incising into the sediment and coming out into the main part of the lake.
I'm backing up all the data so it doesn't get drowned in all the rain.
Yep, and then it should...
So how do you do that?
We've got a hard drive that goes in a waterproof Pelican case that goes in a waterproof bag in the hopes that the multiple layers of water protection will keep the data dry.
Another researcher came in, his name is Dr. Martin Trufer, and he came in just as Hig and I were leaving, actually came in on the plane that we were leaving on. The great thing about his research is he was able to show how deep the glaciers were. He was using a radar system that could see through the ice and down to the bedrock below the glacier.
Yeah, considering the circumstances, which were, quite different and challenging, and the weather, we collected quite an astonishing amount of data, the bathymetry. The results we are really pleased with. We got a lot of detail, also on the deltas. It's been challenging, but it's been fun.
Yeah, to be here for me is really was a really special experience so far. Of course, we got a lot of rain in the last days, but I think it's still, I'm really happy to be here. I really appreciate it so much to be here with other people, and it's a really unique experience for me because usually I would never get in such environment on my own, because it's not an area you could easily access, which makes it even more valuable to be able to be here and study these things. And of course, it's also a lot of fun just to hang out in a bigger group and get the camping situation started, and yeah, just having a good time here, I guess.
Tastes good, a bit crunchy, a bit cold, but otherwise
Basically like a granola bar.
but really healthy. No sugar, no fat.